Jai Hind. The topic which we are going to discuss today is cloud computing architecture. We are also going to discuss different service models which are present in the cloud. So we have already seen what is a cloud computing. It's just a brief overview of cloud computing. So we could say cloud computing refer to the delivery of computing services over the internet, and these services include storage, processing power and software application. That is, basically it allows the users to access the resources and services on demand without the need for physical infrastructure or the local servers. That is, we have already seen, that is, whenever the user is demanding something, sending a demand, accordingly to his or her requirement, the resources would be allocated, and these resources, they could be your storage facility, it could be processing power, or it could be any software applications. We had already seen cloud model. When we talk about the cloud model, we are having two categories in this. One is the service model and another one is the deployment model. Service model, it says on the basis of what kind of service the user is availing, we are having three model: IaaS, PaaS and SaaS. Similarly, in what way we are implementing the cloud on particular this kind of parameter, we are having the deployment model. We are having four deployment model: private cloud, community cloud, public cloud and the hybrid cloud. Private cloud, that is when we are implementing the cloud specifically for a single organization, then we go for the private cloud. Community cloud, when multiple organizations, they come together and form a community. For example, your media, your education sector or your entertainment sector, then in that field we could form the community cloud. Public cloud, it is available to all the users, whether it is an individual or whether it is a particular organization. And when we club together, that is private and with the public, we got the hybrid cloud concept. So let's start with the service model. The very first service model is the infrastructure as a service, that is IaaS model. IaaS, basically it provides virtualized computing resources over the internet, that is infrastructure. It basically provides the infrastructure related things to the user. Users have control over the OS, storage and networking components, that is you will get the infrastructure over the internet, and on that infrastructure, what kind of platform, what kind of OS you want to deploy, that is your choice. What kind of networking components you are going to design, that is your choice. What kind of applications are going to run on that particular infrastructure, that is your choice. So what we are getting in the case of IaaS, we are only getting the infrastructure. In the case of IaaS, they can provision and manage virtual machines. How these infrastructure components being provided to the user? It is with the help of virtual machines, that is the virtualization of resources being done, and on the basis of these various virtual machines are created, and these virtual machines are assigned to the users. And these virtual machines, they can contain the storage facility, they can contain the computing power, they can contain the network components. Example of the IaaS providers: Amazon, that is AWS, it is providing EC2. Similarly, from the Azure, we are having Azure virtual machines, and from the Google, we are having Google Compute Engine. So in the case of the IaaS, we could say what we are getting compute, we can go for the storage part, we can go for the network part, and we can go for the load balancers. That is, we can virtualize these four components, and on the basis of these, virtual machines are being created and allocated to the customers. Now the second service model is platform as a service, that is PaaS. In this case, the user is availing or getting the platform over the internet, and when the user is getting the platform, no doubt infrastructure is associated with the platform. So in this case, infrastructure and platform is from the CSP side. So PaaS, it offers a platform. And why we require the platform? We require platform basically for development, for testing part, for the deployment of the application. So for all these things, the user needs certain platforms, and instead of going for on-site, the user may go for the cloud part. So users, they can focus on application development without worrying about infrastructure management. It provides the user with the freedom to make a choice among the various kinds of deployment platforms available over the cloud. The PaaS providers manage the underlying infrastructure, including servers, storage, and networking. That is, it provides a hassle-free environment to the customer. The customer need not to worry that if he or she wants to use a particular platform, then what kind of underlying infrastructure it should adopt, because all the things, all these aspects are being taken into consideration from the CSP side. Developers, they can leverage pre-configured environments, development frameworks, and deployment tools. So in this case, the major players in the PaaS, they are Heroku. From the Google, we are having Google App Engine. From the AWS, we are having the product AWS Elastic Beanstalk. So in the case of the PaaS, we can get programming language support, we can get application frameworks over the internet, we can get database support over the internet, and other deployment testing tools, they are also available over the cloud. The next service model is the SaaS, that is software as a service. Now in this case, the user is just going over the cloud and using an application. All the inherent things which are below the running below your any software, that is taken care of by the cloud service provider. So SaaS, it delivers software applications over the internet, and basically it is being done on a subscription basis. The users, they can access and use applications directly through a web browser, or sometimes certain APIs support is also being provided to the customer. It depends what kind of service the user is availing over the cloud. The provider hosts and manages the underlying infrastructure, application, and data. That is, all these things are going to be managed by the provider. That is your CSP. Users, they can typically customize certain aspects of the application to fit their needs. That is, they cannot totally, you could say, redo the application features. They can only demand, okay, this what I need in my application, and if it is feasible from the cloud provider side, then CSP will definitely satisfy the requirements of the user. And certain examples over for the SaaS are Salesforce. Then from the Microsoft, you are aware, you are already using Microsoft Office 365 and Google Workspace. So from the SaaS, what we are getting over the internet, we are getting business services, business applications, they are there. It could be a financial services or any, you could say, business forecasting applications. Then document management support, you can get over the cloud. Social networks, it also kind of support being provided over the cloud through SaaS. Then there are certain mail services which are again providing the facility to the user over the cloud. So what we have learned so far, on the basis of this, we can say then that whenever we are using any application, then there are certain layers. The first thing is the networking, storage, servers, all these are my infrastructure part. Above that, we can go for the virtualization if I require. If I don't require, then it might be absent on my local system. Above that, we are having operating systems, middlewares, runtime applications, data part, application part. So this is how the things are being provided to us, how we are when we are using a certain application. When we are saying on-site management, that is, we are not on the cloud, then all these things are provided to us and all these things need to be managed by the client, that is by the customer. But once we are using in or availing IaaS, then in that case, up to here, everything is needed to be managed by the CSP. And above this, all these things need to be managed by the user. That is, when you are using IaaS, you are only getting the hardware support, and above that hardware support, whatever you want to do, whatever you want to run, that is your choice. Then comes the PaaS, that is platform. So in the case of the platform, up to here, everything need to be taken care of by the CSP. Only the application and data part is to be addressed by the client. But when you are availing SaaS, that is software as a service, all these components, they are being managed by the CSP. You don't need to worry where data is going to be stored, what kind of runtime support is being provided, what kind of hardware support is being used. All these things taken care of by the CSP. You are just logging in through the web browser or using certain APIs to avail those software services. So here we are having the hardware. Above that hardware, we could have CPU, memory, disk bandwidth, and so on. Here, when we are using the IaaS, we need to go for the virtualization. So here we are having a virtualization, you could say virtualization layer, and this virtualization layer will virtualize the infrastructure, hardware infrastructure, which is required by the user. Above that, we are having the platforms. These platforms, they could be, for example, it could be your .NET, Java, Python, and if I talking about the storage, it could be my databases, various kinds of databases, file, and so on. And above that, we are having applications. It could be my business application, multimedia application, web services, etc., etc. So here, up to here, we are having IaaS. So data centers, these are the examples: Amazon EC2, GoGrid, FlexiScale. These are the various applications you can use when you are availing the IaaS. When I'm talking about the PaaS, in the case of the PaaS, I'm having Google App Engine, Microsoft Azure, Amazon database support is my SimpleDB S3. Similarly, when I'm talking about the SaaS, then I'm having Google Apps, Facebook, YouTube, Salesforce, and so on. So if I say ki what is the IaaS reference implementation, that is when I'm implementing the IaaS, what kind of architecture I should follow, then in that case, here is my physical infrastructure. I could go for data center, I could go for adopt for clustering, distributed computing, and I could have the desktop. So here, and this physical infrastructure, I'm having three components in this case. One is physical infrastructure. Above that, I am having infrastructure management services, and on the top, I am having the user services. So physical infrastructure, my hardware. Above that, infrastructure management service, that is for monitoring, reservation, scheduling, QS, billing, VM image, VM pool. These are the various infrastructure management services, and these services, they are directly interacting with my hardware. And after that, we are having the user interface, and for the user interface, I could have the web service, portals, and REST APIs. So here, the third party IaaS cloud, that is my CSP, it is provisioning, that is creating these services with the help of these management services and providing the support to the user through web-based management interface. In the case of the PaaS, I am having PaaS cloud service provider. Here again, no doubt we need a physical infrastructure, so I'm having physical infrastructure, but here I'm having PaaS core middleware, that is the you could say the layer which is providing the PaaS facility, and it is talking about elasticity, runtime applications, resource, then user, application, billing part, and so on. Again, the user, how the user is interacting with the PaaS core middleware, it could interact with the help of web-based or with the help of programming APIs or libraries. So what are the various, you could say, common cloud computing use case? For the data storage and backup, we could go for the cloud. Storage, software development and testing part, again, we are having applications available over the cloud for web and mobile applications development, deployment. Then for the big data analytics, or you could even the disaster, for the disaster recovery, we could avail the services over the cloud. So these are just a few, you could say, common cloud computing use cases where you could avail the services over the cloud. Let's talk about the cloud architecture. This is a general architecture, and this architecture is having two components. One is front end, another one is your back end. At the front end, we are having the client infrastructure, that is your laptop, mobiles and so on. And at the back end, that is the kind of support IaaS, on the basis of IaaS, PaaS, SaaS, whatever service you are availing, we are having at the back end. And front end and back end is connected with the internet support. Within the back end, we are having again various components: application, service, runtime, cloud, storage, infrastructure, management and security. So two parts, front end, back end. Front end is used by the client. It contains client-side interfaces and applications that are required to access the cloud computing platform. The front end include web servers or APIs. You may use thin and fat clients, tablets, mobile devices and so on. At the back end, it is used by the service provider. It manages all the resources that are required to provide cloud computing service. It includes a huge amount of data storage, security mechanism, deployment models, servers, traffic control mechanisms, load balancers, and so on. So client infrastructure is a front-end component. It provides GUI to interact with the cloud. Application, maybe any software platform that a client wants to access. Service, it could be your IaaS, PaaS and SaaS. When we are saying runtime cloud component, then runtime cloud, it provides the execution and runtime environment to the virtual machine, that is your virtual machine support. The storage component is responsible for providing huge amount of storage capacity in the cloud to store and manage the data. Infrastructure, it provides services on the host level, application level and network level. The cloud infrastructure, it includes hardware and software components. It can be servers, storage, network devices, virtualization softwares and other storage resources which we need to support the cloud computing model. Another important component is management, because we need to manage all these things within the cloud. So management is used to manage the components. For example, if you are using SaaS, then it is going to be application services. If you are using PaaS, then runtime cloud. If we are talking about the IaaS, then storage and infrastructure and so on. Again, security issue is also need to be addressed in the case of the cloud. So it is the part of the management module. Security is an inbuilt backend component of cloud. It implements security. Now this security aspect from the CSP end. It is not talking about the security features being deployed by you at your site. Internet, it is a medium through which front end and back end, they can interact among themselves. We are having another important computing reference architecture which has been developed by the NIST, and basically why we need a NIST cloud computing reference architecture, because it provides a technical reference. Here in the case of the generalized cloud architecture, no technical reference has been made. Categorize and compare services of the cloud, analysis of security, interoperability and portability. All these issues, they have been addressed in the NIST Cloud Computing Reference Architecture. So the conceptual reference architecture, basically it involves 5 actors, which we are going to see just now. Each actor is acting as an entity which participates in cloud computing. So this is the NIST architecture of the cloud. So what are 5 actors? We are having cloud consumers, cloud auditors, cloud providers, cloud broker, and the cloud service management. So in this case, the cloud consumer, that is the consumer part, consumer, that is you. We are having auditors, we are having cloud providers, we are having the cloud brokers, and under these various actors, we are having various you could say services or the management part being support, which are being provided under that particular actor. So we are having cloud consumer. It is an individual or organization that engages in a business partnership with the CSP and utilize their services. It could be an organization, it could be a general user, individual user. Cloud provider, a person, it could be organization or entity that is accountable for offering the services to individuals or entities who are interested in them. Cloud auditor, a party capable of conducting an impartial evaluation of cloud service as well as assessing the performance, security and the operations on the cloud implementation. So what are the role? Security auditing, privacy and the performance auditing, all these things need to be taken care of by the cloud auditors. Then we are having a cloud broker. It is an entity responsible for managing the utilization, performance and delivery of cloud services. Additionally, they act as a mediators between the cloud providers and consumers, negotiating the relationship between the two parties. And what are the services being provided by the cloud broker? What are the roles of the cloud broker? Service intermediation, service aggregation and service arbitrage. Cloud carrier, an intermediary that facilitates the connectivity and the transportation of the cloud services from cloud providers to cloud consumers. And when we are saying cloud provider, we are having service layer, that is IaaS, PaaS, IaaS support. Resource abstraction and control layer is there. Physical resource layer, that is our hardware and facility layer is there. For the management, we are having business support, provisioning, configuration, portability, interoperability management part, security and privacy. All these things are under the actor cloud provider. Upfront planning, that is the cloud best practices. When we say prioritize upfront planning to understand capacity needs and avoid unexpected production glitches, continuously test the performance during the architecture design phase, and the security is very important. Implement robust security measures to protect against unauthorized access, safeguard all layers of the cloud infrastructure. And how we can go for it? Through data encryption, patch management and strict security policies, considering adopting zero trust security model, and it will enhance the protection in hybrid and multi-cloud environment. Disaster recovery readiness, automate recovery process to minimize costly downtime and ensure swift recovery from service disruptions. This is very much requirement in the cloud. Implement monitoring mechanism to track capacity and utilize redundant networks for a highly available architecture. Maximize performance, optimize computing resources, that is we need to monitor the utilization of resources, and optimization need to be done. Efficiently manage and allocate the resources to manage the optimal performance levels. Then the cost optimization is also required. Why? Because leverage automated processes, managed service providers and utilization tracking to reduce unnecessary cloud computing expenses. Regularly reviewing and optimizing the resource allocation, and this will ensure the cost effectiveness in the cloud environment. We are having cloud computing adoption risks available in the cloud. The very first one is technology immaturity, that is lack of worldwide adopted standards, use of closed proprietary technologies, and so on. Data security, migrating workloads to a shared network and compute infrastructure increases the potential for unauthorized exposure. So authentication and access technologies become increasingly important in this part. Another thing is security management. The providers must supply easy controls to manage firewall and security settings for the applications and runtime environment in the cloud. Vendor lock-in is there, that is interoperability constraint. So low level of portability of application and services based on the cloud. Contract and exit strategies, limitations on sharing of transferring of the data. Reliability is another risk involved when we go for the cloud. High availability will be a key concern. IT departments will worry about a loss of service should outage occurs. Compliance, another important risk involved with the cloud. Complying with SOX, HIPAA and other regulations may prohibit the use of cloud for some applications. Comprehensive auditing capabilities are required. Less control, many companies and governments, they are uncomfortable with the idea of their information located on the systems which they do not control. So the provider must offer a high degree of security transparency to help put the customers at ease. So these are the various risks which are involved when you are moving your traditional business to over the cloud. These are the references being used while preparing the slide. So what we have discussed in this video, we talked about various service models, 3 service models basically, and then the generalized architecture and the NIST reference architecture for the cloud. This is all about for today. Thank you and Jai Hind.